A very good morning, dear children. Today we are going to see chapter number 6 of General Science Measurement of Physical Quantities. Now, children, observe and discuss. How are the various articles and materials shown in the picture measured? So, brinjal, pumpkin, onions, potatoes, French beans, and many similar vegetables are weighed in grams and kilograms. So we call it as weight in our day-to-day familiar language. But actually its mass is measured. The spool of thread has thread which is measured in meters. The bunch of leafy vegetables, that is green leafy vegetables, are measured in numbers. Milk in glass is measured in liters. There is a diamond in the gold ring. The purity of gold is measured in carats. 24 carats means 100% pure gold. In case of diamond, carat is the measure of the mass of diamond. 1 carat diamond is equal to 0.20 gram or 200 milligram. The cloth is measured in meters. Okay, so these are the articles and materials, and these materials or articles can be measured in different units. Now children, let us see physical quantity. In our day-to-day life, we measure many things such as the weight of fruits, vegetables, food grains, temperature of the body or some liquids, volume of liquids, density of various substances, the speed of vehicles, etc. But the quantities such as mass, weight, distance, speed, temperature, volume are called as physical quantities. A value and a unit are used to express the magnitude of a physical quantity. For example, Swarali walks 2 kilometers every day. In this example, 2 is the value and kilometer is the unit used to express the magnitude of the distance, which is a physical quantity. Children, there are two quantities, that is scalar and vector quantity. Now let us see first of all scalar quantity. A quantity that can be completely expressed by its magnitude alone is called as scalar quantity. For example, only magnitude, that is a value with a unit, is used to express quantities such as length, breadth, area, mass, temperature, density, time, work, etc. All these are the quantities that we need. For all these quantities we need, that is length, breadth, area, mass, temperature, density, time, work. All these are quantities and we require for all this quantity value with their unit. For example, we say that the length of a tunnel is 2 kilometers. The fever, that is temperature, is 101 degree Fahrenheit. Okay, or 101 degrees Celsius. Fahrenheit is also the unit of temperature. Okay, so these are the units with their values. Okay, and due to that, these quantities are called as scalar quantity. Now children, let us see vector quantity. The quantity that is expressed completely only when magnitude and direction are both given is called as vector quantity. Displacement, velocity, these are the vector quantities. For example, a displacement of 20 kilometers towards the north, the aeroplane flying at velocity of 500 kilometer per hour towards Mumbai. So these are the vector quantities. Now mass. The amount of matter present in a substance is called as its mass. Matter has a natural tendency to resist a change in its state, and that is called as inertia. Means that is the natural tendency and that shows change in its state, that is called as inertia. Mass is qualitative measure of the inertia of an object. The larger the mass, the greater is the inertia. Now mass is a scalar quantity. It does not change from place to place anywhere in the world. The quantities mass and weight are however different. Now gram and kilogram, these are the units of mass. When we use 2 column balance in a shop, then we are comparing their masses. So that is the main difference between mass and this weight. Okay. Now let us see children concept weight. What we measure in grams, kilograms, that is mass and that is not weight. The gravitational force that acts on this mass, that is called as weight. Means gravitational force is acting on the mass and that is nothing but weight. So in short, we can say that children, weight is nothing but product of mass and gravitational acceleration. That is W is equal to M into G. The gravitational force by which the earth attracts an object towards its center is called the weight of the object. So therefore, weight is a vector quantity and it is different at different places on the earth. Okay, so this weight is a vector quantity and it changes from place to place on the earth. Now use your brain power. Why would the weight of an object be maximum at the poles and minimum at the equator? The weight of a body is the pull of the force by which it attracted towards the center of a earth. Since the equator is more far from center of earth as compared to that of distance of poles from the center of the earth. Hence, the more the distance will be, the less will be the weight measured. And this is the main reason why the weight of an object is maximum at the poles and minimum at the equator. Now, second question, children. Why is the weight of an object at a high altitude less than its weight at the sea level? So the weight will be less at the place where the gravitational force is less. As the object rises to higher altitude, it is moving away from the center of the earth. The gravitational force at the higher altitudes will be lesser as compared to that of at sea level. And therefore, weight of an object at a high altitude is less than its weight at the sea level. Now next question, will it possible to use one and the same unit to measure physical quantities such as mass, weight, distance, velocity and temperature? So no children, it is not possible to measure all the physical quantities in one and the same unit. Because in everyday life, we are measuring many different physical quantities. As these physical quantities are different from each other, so there is having specific unit for all these physical quantities and therefore different units are used while measuring different quantities. Now do you know? Our body has weight because of the gravitational force of the earth. This gravitational force of the moon being less, so our body will turn out to be less there. Our mass, however, is the same at both the places. Now, let us see one experiment, children. Try this. Standardized measurement. Take a ball of string. Let one student from the class measure 4 handspans of the string and cut it there. Let each of the other student in the class cut 4 handspan of the string too. Now hold all the pieces together by one end. Are they all of the same length? So no, because everyone's handspan is of different size. Okay. So what is the meaning of this handspan, children? So the distance between the tip of the smallest finger and the tip of the thumb when spread is called as hand span. So the distance between tip of the smallest finger and the tip of the thumb when it is spread, that is called as hand span. Now second question. Now measure the length of a bench by means of the span of your hand. Ask your friends to do the same. Did each of you obtain the same measure for that bench? What could be the reason? So when you are measuring the length of a bench by means of your span of your hand and you are telling to your friends also. So obviously your measure and your friend's measure will not same because everyone's hand span is different. Okay, everyone's distance between this hand span means distance between this thumb and this small finger, that distance is variable, and due to that everyone's that distance will not be same. Now, standardized measures are required for measuring these things, and such measures are called as standard units. We have to measure many physical quantities accurately. So, for to measure any physical quantity, we have to use specified unit for this. For example, meter, that is small m, is the specified unit for measuring length. A certain distance has been accepted as the standard for 1.0 meter. So why is there a need for such a standard unit? So suppose the span of a hand is accepted as the unit for measuring length. Then with this unit we can measure lengths of cloth as 2 hand span, 3 hand span and so on. But however, the length of the cloth measured by each one of us will come out to be different. And that is why a hand span cannot be standard unit for measuring this length. Now always remember, prevailing systems of measurement. There are two systems of measurement, that is MK system and CGS system. So in this system, distance is measured in meters, mass in kilograms and time is measured in second. In CGS system, this distance is measured in centimeter, mass is measured in grams and time is measured in second. In the MK system of measurement, distance, mass and time are accepted as the fundamental quantities. So these three quantities are used to measure all other quantities. Okay, and due to that these quantities, these three quantities, that is distance, mass and time, these are called as fundamental quantities. Now complete the following table. Physical quantity, that is given mass, distance, time and speed. Now in MK system, mass has unit kilogram. In CGS system, mass has unit gram. In MK system, distance has unit meter, and in CGS system, distance has unit centimeter. MKS and CGS system, both in both these, time is measured in second. Now speed has the formula, that is distance upon time, and due to that speed has the unit meter per second in MK system and centimeter per second in the CGS system. Now children, there are many physical quantities, but majority of them are related to each other. You have learned that now quantity, that is speed, is the ratio of distance and time. Means speed is equal to distance upon time. Thank you children for watching the video and for your attention.